Welcome to another video. In this video we'll be looking at an addition to my camera boat that I use while carp fishing. This is a modified bait boat, and I've added a winch and a camera, and it's all radio controlled. I'll show you it in operation and then we'll discuss the parts. Standard radio control handset. Pulling back on the stick. We see the camera slowly load to whatever height I want to film at, and that includes an 8-foot down lake bed. This is untested in the field, so how it'll arrive at the lake bed and sit is open to, well, whatever happens. So there it is. The first problem or issue I have that I can see is how will I know when I've reached the lake bed. The line will go slack, but bearing in mind that the boat will be quite a way away from me, so I need some type of strain gauge or indication of when the winch has finished its job and when the camera sits on the lake bed. If I stop it short of the lake bed, then the line will always stay relatively tight or taut. But it's when, so I think what I need is some markers on the line so that when I know it's definitely at 8 foot, I can see the marker appear on the line. But any suggestions, please leave them in the comments below. It'd be very welcome. This is a work in progress, as all my projects are. So let's see it return back to the boat. Now I can stop it at any point, so if I was to keep an eye on the boat, possibly with binoculars if it's out of sight, easy sight, if I was to stop it when it just left the water, okay, but I've put heavy enough break and strain line on it so that if the winch continues to pull it over the rear pulley and into the boat and it does snag up, it won't automatically snap off and drop into the lake. Well, that's the theory anyway. So I'll lift it from our carpet lake bed towards the boat. Now I've chosen a motor which only does 10 revs per minute because I wanted a high torque motor. I had another project in mind where I was going to be lowering an object quite a bit heavier to the lake bed, and I wanted to be able to stop it at any point and not have it run away. I didn't want the object to turn the motor rather than stay still. A relatively light object like this camera is easily held in place by the internal braking of the motor. So here we see a typical run where the camera is touching things as it comes on board. There we go. That is a classic example of it trying to snag up, but all the rounded edges encourage it to go on board. And at this point I'll pause the video, move the camera back out of the way so we can have a look at the parts, the individual parts of the project. You rejoin me with the camera positioned for another dive. What we see is the camera, which is one of the 4K high-res clone type cameras that are readily available with a waterproof case. My plan is to set the video recording going on shore and then set the boat off on its merry way. I could use Wi-Fi to monitor the video throughout the journey, but I don't think it'll be necessary, and it saves battery life if you don't have Wi-Fi powered, so it'll just be taking dumb footage on its way out to the dive site. Issues I can see are it could spiral on its way down, but seeing as I'm not entirely sure which direction I want to be filming, the spiral could be seen as a panoramic effect that may catch me more video than a static view. Okay, the promised look at the parts. 12-volt motor, high torque, which means there's a gearbox inside the motor. It's got a, as said previously, it turns at 10 revolutions per minute. Not suitable for every application, certainly not for driving a boat, but for lifting reasonable weights it's absolutely ideal. It's compact and can be powered easily. Moving on to the power, we'll zoom in and take a look at the motor. Okay, so nothing much to see. The outer casing of the motor, the output shaft of the motor is slightly off centre, which is always the case when there's a gearbox involved within the motor. It has a shaft sticking out the output side, which is convenient. I've got myself some bobbins and they're arrowdated to the shaft, so it is a pretty ruthless way of attaching them, but rather than have custom made drive bobbins with locking devices, this will do. How did I arrive at the bobbin size? Well, it all stems from the fact that I want to reach a lake bed which is typically 8 foot below the water line. So the bobbin only had to be sufficiently large enough to carry the line of suitable length to cover the 8 foot depth, plus a few more turns around the bobbin, because there's more mechanical efficiency in something that's wound around. In other words, you don't want to be pulling onto the knot that's attaching the line to the bobbin if you can help it. Being a fisherman, hopefully the knot will hold, but why go to the bother of having to even test the knot? A few lines of spare line around the bobbin enables a much improved experience. The line, it's a 50-pound braid attached to the camera via the waterproof housing with a 6-turn tucked blood knot. Time will tell if that's the definitive answer, but that's what I'm going with for now. Throughout the project, I've had to be aware that there is water about, so most connections, electrical wise, I've covered in the hot glue. This can be dug out so you can get at the parts if necessary, but it'll provide quite a good waterproofing for now. The motor, the motor is attached to one of the bait containers at the back of the boat. This particular boat has 2 containers side by side that flip up when you want to eject any bait. The primary function of this boat was a bait boat, so I've utilised one side, i.e. the right hand side, for the camera assembly. Getting back to the motor and its mounting. With the camera came a number of clamps, including handlebar clamps, and one of them suited the motor. So that's how it's mounted. It's bolted to the tub, the bait tub, and it allows the motor to slide in. There's hardly any alignment issues with such a setup as this. It's just line going between 2 points. So that's the motor. Now the motor, being 12 volt, powered by these rechargeable batteries, which can be seen to the left of the motor. The batteries we see in this view are just temporary 12 volt. I've got some flatter multi-cell batteries once I fit the necessary connector to fit my system. So 12 volt powers the motor, but of course we want to be able to switch it on and off to wind the camera up and down. I chose to do this with a switch that's controlled by a servo. The switch is a 3-position toggle switch, center off, one side on, the opposite side on, sprung center off. So it always defaults to the off position so the motor isn't running. A servo, because we can control it with a radio control channel, a servo is ideal for flipping this toggle switch from one state to the next. A high torque servo was chose because, again, we're moving a mechanical device, in this case the servo, and I wanted it to definitely move the toggle switch. I didn't want it failing and the camera being left dangling on the lake bed. So let's zoom in on the horn of the servo, and you can see that it's, well, can you? Trust me, it's over the toggle switch. There's a hole in the servo horn that's been enlarged enough to encompass the toggle switch lever. Now you notice this is all covered in hot glue. It serves a couple of reasons. It keeps everything together, which aids the mechanical efficiency of it, and hopefully it'll just give that added strength to the servo horn so that it doesn't fail and cause problems. While we're zoomed in, I'll move the servo horn and we can see the toggle switch moving. So that's a servo horn attached to one channel, a spare channel, on the radio control system. There's not much left now. At the rear of the bait tub there's another of the bobbins which is bolted in place in the corner. It doesn't have to spin. It's round enough and smooth enough. The plastic penny washers, or nylon as they probably are, aid the camera coming aboard, resist any snags. So I think that just about covers the initial project. It will develop. So thanks for watching, and please, if you have any ideas about improving the system, including monitoring the tension on the line from the shore with the bait boat at distance, if you have any ideas, please leave them in the comments. Until then, it's Brian, aka F1 Pit Pass, signing off. Thanks for watching. Catch you in the next one. Bye.